Hello students, welcome to Learner's Planet, Theory Session 3 of Periodic Classification of Elements. In our last session, we discussed about the classification given by Mendeleev, about his periodic law and also its periodic table, about its drawbacks and also the merits. Now in this session, we will be discussing about the periodic law given by Mosley and about the long form of periodic table, how the elements are arranged. Now starting with the Mosley's classification. Who was Mosley? Now this Mosley, he was a young English physicist. What he did was, he measured the frequencies of the X-rays emitted by a metal when the metal was bombarded with high-speed electrons. Now what happens here, students, that say if I am taking this metal plate, right, metals like sodium which have got a single electron in their outermost orbit, now what we are doing is we are bombarding this with fast moving electrons. So now what these fast moving electrons are going to do? What they'll do, these are fast moving electrons. Now what they'll do, they'll transfer their energy to the metal. Now as the result of which certain rays are emitted. Now these rays are called what? These rays are X-rays. Okay. Now these X-rays, what they do? What he made use of these X-rays. Now what did he conclude? That the frequencies of the X-rays he measured, and what he discovered was, he discovered that the square root of the frequencies of prominent X-rays emitted by a metal was proportional to the atomic number and not the atomic weight of the atom of that element. Now what do you mean by this? That when we are bombarding what? We are bombarding fast moving electrons on the metal surface. As the result of which, what is happening? These X-rays are emitted. Now what he did, that he took the root of their frequency and plotted a graph with their atomic numbers. With atomic numbers of the element. And what he obtained was, he obtained a straight line. And when he did it with the atomic mass, the graph was erratic. That there was no relationship between them. So what he concluded, that the frequencies of the X-rays was proportional to the atomic number and not the atomic weight of the atom of that metal. Now what can be concluded from here? That the properties of the elements or an atom is determined by its number and not by its mass. So he suggested that the atomic number Z and not the atomic weight should be the basis of the classification of the elements. Now as he discovered that X-rays, these are emitting out X-rays is one of the property of the metal. Now that depends on the atomic number and not the atomic mass, by plotting a graph between the frequency and the atomic number or the frequency and the atomic mass. Now he suggested that if the elements are arranged in the increasing order of their atomic numbers, then the properties of the elements are repeated after definite regular intervals or periods. So he suggested that if we are arranging the elements in the order of their increasing atomic numbers and not the weights, which Mendeleev did. Mendeleev arranged them according to their weights. Mosley is arranging them according to their atomic numbers. And he has got this evidence also with him that the properties depend on the atomic numbers. Then he suggested that the properties are repeated. Okay. Now let's see how he arranged these elements. Based on this, there was modern periodic law, and it states that physical and chemical properties of elements are a periodic function of their atomic numbers. I told you that the physical and the chemical properties depend on the atomic numbers. If the elements are arranged in the increasing order of their atomic numbers, the elements with similar properties reoccur after certain fixed intervals or periods. I'll elaborate this in the periodic table. Now the long form of periodic table, or the periodic table which we are studying these days, or which we have, is this periodic table is based on Bohr-Bury concept of electronic configuration. So Mosley gave the basis of classification as atomic number, but Bohr-Bury gave the basis of classification as electronic configuration. And this was proposed by Rank, Werner, Bury and others, and this is known as long form of periodic table or Bohr's table. So what periodic table we have today is Bohr's table, and what it is based on? It is based on the concept of electronic configuration. He suggested that the physical and the chemical properties of the elements are the periodic functions of their electronic configuration. The arrangement of elements in modern periodic table is based on their electronic configuration. Now let's see how these elements are grouped, or the features of this periodic table. The characteristics of long form of periodic table. What all it consists of? Just like Mendeley's periodic table, it consists of vertical columns. So the vertical columns in the periodic table are called what? Groups. So how many groups are there in the periodic table? There are 18 groups in the long form of periodic table. So the vertical columns are called as groups, and the number of groups in the periodic table are 18. The horizontal rows in the periodic table are called periods. There are 7 periods in all, such that each period has consecutive or continuous atomic number. So how many periods are there? 7. And they have got a continuous atomic number. Like if I write here lithium and beryllium and boron, then carbon, then nitrogen, then oxygen, then fluorine. So they'll have continuous atomic number. That is, lithium has the atomic number 3. Beryllium has the atomic number 4. Boron has the atomic number 5. Carbon 6. Nitrogen 7. Oxygen 8. Fluorine 9. And after that, neon 10. So what it is saying, that the elements in the periods have what? They have consecutive or continuous atomic number. Now the number of elements in a period corresponds to the maximum number of electrons which can be accommodated in its one shell. So the number of elements, say if I am taking this period, that is the second period. So the number of elements here are how many? Let's take 1, 2, 3, 4, 5, 6, 7, 8. So there are 7 elements in the second period. How many electrons it can accommodate in the second shell? It can accommodate 8 electrons. Whereas if I talk of potassium, there are 18 elements in this period. So this can accommodate, in the fourth shell, it can accommodate 18 electrons. So what is it saying, students? The number of elements in a period corresponds to the maximum number of electrons which can be accommodated in its one shell. So the next is the number of periods to which an element belongs is given by its quantum number, that is n, that is the number of outermost shell as counted from the nucleus. Say your lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, they belong to second period. Now this can be indicated by the quantum number n, or I can write it as 2n. Likewise, if I am taking sodium group, so it would be 3n. Potassium, 4n. What does this mean? That 2 is the outermost shell counted from the nucleus. That is, if there is, like, say this is your atom, now in the center is the nucleus. So 2n means there are 2 shells in an atom. So this is n is equal to 1 and this is n is equal to 2. So the number of period, what it tells, the number of periods to which an element belongs is given by its quantum number, that is the number of outermost shell as counted from the nucleus. Now let's take a few more features of this. The strongly metallic elements, alkali metals, alkaline earth metals, occupy groups 1a and 2a respectively on the left hand side of the periodic table. I'll show you the periodic table and I'll explain this to you there also. The transition elements are accommodated in the middle of the table in 3 periods. The non-metallic elements are placed on the right hand side of the periodic table. And the last is the rare gases are placed in the 0 group at the end. Now let's see how this periodic table looks like. There are few more. The rare earth elements like lanthanides and actinides are called inner transition elements, and they are kept outside the periodic table to mark their peculiar properties. The elements in group do not have consecutive atomic number. Consecutive means continuous. Each element in a group has same number of electrons in its outermost shell, and hence all the elements of a group have similar chemical properties. I'll show you here. Say if I am arranging this, that is lithium, sodium, potassium, rubidium. So this is first A group. Now the atomic number of lithium is 3, sodium is 11, potassium is 19. The number of electrons in the outermost shell is 1. If I'll arrange it like, I can arrange it as 2 and 1. This I can arrange as 2, 8 and 1. This I can arrange as there is also 1 electron in the outermost shell, 2, 8, 8 and 1. So these elements, as they have got similar number of electrons in their outermost shell, so what are they having? They have similar chemical properties. That is, all these elements, what will be the valency of these elements? It would be 1. The type of oxides they are forming or the type of halides they are forming, it will be the same. That will have the similar properties. The formula of the oxides and the halides will be the same. Their properties of course differs. The elements in 0 group are called rare gases or noble gases. So these elements are arranged at the end of the periodic table or at the last group, and these are called as noble gases. All the elements in this group, with exception of helium, which has 2 electrons, has 8 electrons in their outermost shell. So in the last that is 0 group, they have got 8 electrons. Now this is your periodic table. What I told you was that in the modern periodic table there are how many periods and how many groups? There are 7 periods, that is 1, 2, 3, 4, 5, 6, 7. This way the period goes. This is the first period. This is the second period. This is the third period. The fourth period. This is the fifth period, the sixth and the seventh. Now these are the groups, the vertical columns. That is, this is the first group, second group, third, fourth, fifth, sixth, seventh and eighth, and the 0, 1. Now how are these arranged? They are arranged as 1A, 2A. Then we have got 3A on the left hand side. Okay. Now in this case, the elements present in the period, let's talk of the period. What is it? They have got a continuous or consecutive atomic numbers. That is, I have shown you the example of lithium. We'll take up with sodium. That is, sodium has 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17 and argon 18. That is, they have consecutive or the continuous atomic numbers. But if I talk of groups, so if I am moving from beryllium to barium, what is happening? Is the atomic number consecutive? After 4 there is 12, after 12 there is 20, after 20 there is 38, then is 56 and then is 88. So it's not consecutive. Then I also told you that the period number is given by the quantum number n. N counts what? N counts the number of shells from the nucleus. So it would be 3n, this would be 4n, then 5n, then 6n and then 7n. Now this suggests what? If I am saying 3n, it means an atom or the atom has got 3 shells. 4n means the atom has got 4 shells. Now this way your groups and periods are arranged. Now just see this side. This is 1A and 2A. These are what? These are metals. That is, we have done metals and non-metals, and you must be aware of the properties of metals now. What are metals? These are electropositive in nature and they can lose electrons easily. So what are the metals here? Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. These are called what? Alkali metals. Why? Because they get dissolved in water and give an alkaline solution. Then we have got alkaline earth metals. That is, they dissolve in water and give a basic solution. But these metals are found in the earth crust. So they are called as alkaline earth metals. And we have got here beryllium, magnesium, calcium, strontium, barium and radium. I also told you that the elements in a group have got similar properties. They have got similar number of electrons in their valence shell. So these are metals on the left hand side. Now moving to the right hand side, what are they? I told you, what are they? Boron, carbon, nitrogen, oxygen, fluorine. What are they? These are non-metals. Okay, and these are also called as p block elements. We'll discuss it later why they are called so. So what are these elements? These are all p blocks or the non-metals. And you are the 0 group. Helium. How many shells this helium has? This belongs to the first period, that is only n. So how many shells this helium has? 1. And it has got how many electrons? 2. But rest of them, if we are moving down, that is neon, argon, krypton, xenon and radon, they have got 8 electrons in their valence shell. Now what are these? On the left hand side there are metals, on the right hand side there are non-metals, and in between, students, there are transition elements or the D block elements. I'll also write it here, transition elements. I'll put a note here, these are non-metals. These are what? These are transition So this is transition element. Okay. Now why they are called as transition element? Because they have the properties in between metals and non-metals. That is, they show transition in properties from metals to non-metals. Why these are called as transition elements? Because they are showing transition in properties from metallic to non-metallic. Okay, so now these are their properties is not like metals and also not like non-metals. So these are called as transition elements. Now below the periodic table, students, there are lanthanides and actinides. Now these are called as inner transition elements. That is, these are the transition series within a transition series, or these are the elements within the transition series. That is, lanthanide series. These are after lanthanum. Lanthanum is a D block element or a transition element. So after lanthanum there are 14 elements which are called as lanthanides. That is, cerium till lutetium. These are lanthanides. Then after actinium there are again 14 elements. These are called as actinides. That is, from thorium to lawrencium are what? Actinides. So this is the long form of periodic table, and it is based on the electronic configuration. Now I told you the elements in the group 1A are called what? Alkali metals. These are what elements? These are lithium, sodium, potassium, rubidium, cesium and francium. So these 1A elements, these are what? Alkali, that is lithium, sodium, potassium, rubidium, cesium and francium. Then we have got the second A group that contains alkaline earth elements, that is beryllium, magnesium, calcium, strontium, barium and radium. Now we have got the elements in the group 3A of the periodic table. So what is group 3A? What are the elements in 3A? They are boron, aluminium, gallium, indium and thallium. So these are called as what? Boron family. Then we have got group 4A. Now what is this group 4A elements? What are these? These are carbon, silicon, germanium, tin and lead. Now what are these elements called? These are called as carbon family. Now let's take up few more elements here. The elements of group 5A of the periodic table collectively constitute the nitrogen family and are known as nicogens. Why they are known as nicogens? This nicogen is derived from the word nikos, that is, meaning suffocation. That is, the oxides of these elements, they cause suffocation. So these are called as nicogens. Now what are the elements of group 5A? It is nitrogen, phosphorus, arsenic, antimony and bismuth. Right? These are called as what? Nicogens. Now we have got group 6A. Now the elements of the group 6A of periodic table collectively constitute the oxygen family, and these are known as chalcogens. Now what do you mean by chalcogens? Chalcogens are the ore forming elements, because many of the ores occur as oxides or sulfides. Now you must be wondering, what are the elements here? These are oxygen, sulfur, selenium, tellurium and polonium, and these are called as chalcogens. Now because we have seen in metallurgy that most of the metals are existing as oxides or sulfides. Now the elements in the group 7A are called halogens. Halogen is derived from the Greek word hals, meaning sea, salt, that is sea salt, and geno, meaning producer, that is salt producer. So these elements are salt producer. Now what are the elements, students, here? They are fluorine, chlorine, bromine, iodine and astatine. Now your salt, that is sodium chloride or potassium chloride or potassium bromide, these are all what? These are salts. So these elements are called as salt producers or halogens, and they constitute these. So group 3 to group 8 constitutes the non-metals. Now see, what is this? This is the quantum number, that is 1n. Quantum number what? This indicates the n, that is 2n, that is 3n, 5n, 6n and 7n. One is what? Hydrogen. Hydrogen has got a single shell. I told you that. Say this is hydrogen. I'll make it a bit small, and at the center is the nucleus, and this is single shell. So this is N. Now how many electrons this can accommodate? It can accommodate only 2 electrons. Okay, I told you that the N also, or the number of electrons it can accommodate, also tells by what? The number of elements present in that period, or the number of elements present in the period also indicates the number of electrons it can accommodate. So 1n, maximum number of electrons it can accommodate is 2, and elements in the period is 2. That is, what are the elements? The elements are hydrogen and helium. Now this is a very short period. Now 2n, in the second period there are 8 elements. So how many electrons it can accommodate in its shell? 8. This is a short period. Then 3n, the number of elements the third period has is 8, and the number of electrons it can accommodate is 8. So this is again a short period. Now we have got fourth period. The number of elements in this period are 18, and the maximum number of electrons it can accommodate is also 18. So it is a long period. Now we've got fifth period. The number of elements in the fifth period are 18, and it can accommodate how many electrons? 18, and the period number is 5. This is also a long period. Then we've got 6n, that is, the maximum number of elements in this period are 32, and it can accommodate how many electrons? 32, and this is a very long period. Then we've got 7n. The number of electrons it can accommodate is 32, and this period is incomplete, and this is also a very long period. So students, this is about the periodic table, or the long form of periodic table you can say, or the modern periodic table, or the Bohr's periodic table. The elements are classified like this. Now in our next session we will be discussing about the properties of the elements present. So thank you for listening patiently.